In this video, we will cover drawings for Bohr-Rutherford diagrams of ions. So just a few things to recall as we begin. So that for a neutral atom, the number of protons is equal to the number of electrons. So in the diagrams we have been drawing so far, the number of protons is always been equal to the number of electrons. And when this happens, we get a neutral atom. And so why we call it a neutral atom is that because if we think about the fact that a proton has a positive charge and then an electron has an opposite but equal negative charge, when we add these two charges together, the sum of those charges is equal to 0. And so this 0, or lack of a charge, is what we refer to as a neutral atom. So now atoms can gain or lose electrons, and this is the whole reason behind the formation of these ions. And when they gain or lose electrons, they form charged atoms. Those charged atoms are what we call ions. The element is still the same because the number of protons has not changed. So remember, number of protons defines what the element is. So any element we find in the universe that contains one proton we're going to call hydrogen. And then anything in the universe that we find with 2 protons, for example, in the nucleus, we will call helium, so forth and so forth. So in our example here of an element losing an electron and an element gaining an electron, so if we count the number of protons in the nucleus, we have 1, 2, 3. That tells us our element is lithium based on 3 protons. And then if we count the number of electrons, 1, 2, 3. So this lithium atom here has 3 protons, 3 electrons. If we add together the positive charges with those negative charges, the total charge on the element or on the atom is 0. So here we have our neutral atom. Now lithium can lose an electron, and it will lose an electron in its outer shell. So here it's losing its electron. And when we look at this lithium atom now, it still has 3 protons, but now has 2 electrons. And when we count, or when we add these charges together, so we have our 3 positive charge plus our 2 negative charge from the electrons, the overall charge now on this atom is +1. And so this atom now has a charge associated with it. If we look at our atom down here, the second atom, and we count the number of protons in the nucleus, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total of 9 protons. If we go and look at the periodic table, the element with an atomic number of 9 is fluorine. And if we count the number of electrons, we have 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 protons and 9 electrons. And when we add those charges together, they total up to be 0. So here we have a neutral fluorine atom. Now fluorine can gain an electron, and that's what's happening here. When it gains electrons, it still has 9 protons in its nucleus, but it now has a total of 10 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a total of 10 electrons. So when we add those charges together, so we have +9 from the number of protons, -10 from the number of electrons, or -10 from the number of electrons, we get an overall charge of -1. So our elements can be positively charged or negatively charged when they gain or lose electrons. So why do atoms form ions? So One thing to keep in mind that the electrons located in the outermost orbit of or orbital shell of an atom are called valence electrons. So those electrons in the outermost shell get this special name of valence electrons. Ions are formed because atoms are most stable, are the most happiest, when they have a full orbital shell of valence electrons. Thus, most elements will form ions by losing or gaining enough electrons to have 2 or 8 electrons in their outer orbital shell. So here in this diagram, we have lithium again as our example. So here we have the valence electron in the outer shell. So lithium has 1 electron in that second orbit. That 1 electron in its second orbit is the valence electron. Right below that valence electron is an orbit, is that first orbit, which contains a full shell of electrons. So lithium has 2 choices: try to gain 7 electrons to get a full outer ring here, a full second ring, or lose 1 electron and have a full orbit just below it. So the easiest path for lithium is lose the 1 electron and then have the orbit with the 2 electrons in it. So this is a full valence shell now. So the valence shell is always the outermost shell, and that will include for an ion. So in this case, this ion here with its valence shell has 2 electrons in it. It's full. Lithium is happy. So this can happen in 2 ways. So an atom can lose electrons, leaving it with extra protons, and therefore an overall positive charge. So when an atom loses electrons, it has more positive charges than negative charges, and this gives it an overall positive charge. So the example that we dealt with previously was lithium. Lithium becomes an ion by losing 1 electron. And when it loses that 1 electron, it now has more protons than electrons. So the charge on the ion is equal to the sum of the charges on its protons and electrons, as we talked about. Lithium has 3 protons, a +3 charge, and 2 electrons, which have a total -2 charge. The sum of those charges is +1. The ion, in this case, we represent as Na+1. Let's fix that, since we're talking about lithium here. The ion is going to be represented as the element symbol, which in this case is Li. And because we just have a +1 charge, we can just write a superscript plus sign in the upper right-hand corner of the element symbol. So here is our ion notation, or our symbol indicating that lithium is an ion. So an atom can also gain electrons, leaving it with extra electrons, and therefore attaining an overall negative charge. A fluorine atom becomes an ion by gaining 1 electron. The ion fluorine has 9 protons and 10 electrons. The sum of the charge is -1 when you add together those positive charges on the protons and the positive charges or the negative charges of the electrons. The ion is represented as F1-, or sort of as we did with lithium, it can just be F-. And just note that the charge, again, is in the upper right corner. So that notation is very important. This gives us information here, a lot of information. So here's our fluorine ion in its valence shell. There are 7 valence electrons. And remember that second orbit has room for 8, a total of 8 electrons. So it's 2 in the first and then 8 in the second. So there's room for 1 more electron, which fluorine is able to squeeze in. And when that happens, it now has a total of 10 electrons and 9 protons, giving it more negative charges than positive charges. So now the Bohr-Rutherford diagram for ions are drawn using the same rules as neutral atoms. So the way we've been drawing Bohr-Rutherford diagrams, those same rules apply. So they'll still have the same number of protons and neutrons as a neutral atom, but we'll have a different number of electrons. We'll have a charge and a full shell of valence electrons. So some slight differences in a Bohr-Rutherford ion versus a Bohr-Rutherford diagram for a neutral atom. So now, in an ion, to determine the number of electrons, we can use the following formula. Wherever. Here it is. So the number of electrons in an ion is equal to the number of protons minus the charge of the atom. So for ions, we do not, the number of protons is not going to be equal to the number of electrons. But instead now the number of electrons in an ion is equal to the number of protons minus the charge of the atom. So we'll look at the example of chlorine. So we'll determine our number of protons and we'll have to figure out number of protons, electrons, and neutrons. We'll do protons and neutrons first, and then we'll figure out electrons, since that is, we're going to do that a little bit differently. So number of protons is still going to be equal to the atomic number. That's not going to change. And in this case, the atomic number for chlorine is equal to 17. So we have a total of 17 protons for chlorine. The number of neutrons still determined in the same way, so we're going to take the atomic mass and subtract the atomic number. So in this case, the atomic mass is 13.45, depending on the periodic table that you're looking at, minus the atomic number. This gives us a total of 18.45. We'll round down, so we get a whole number. We always need a whole number for neutrons. So we're going to get a total of 18 neutrons. Now, for the number of electrons, this is where we have to figure things out a little bit differently. So the number of electrons in an ion, and we know we're dealing with an ion because we have a charge here next to the element symbol. So this is equal to the number of protons minus the charge of the atom. And in this case, we have 17 protons, and we're told that we have a charge of -1. So we're going to subtract -1, which now, if we have a negative times a negative, becomes a positive. So we'll have 17 plus 1, which gives us a total of 18 electrons. And this will make sense because we'll have one more negative charge than positive charge, which should give us an overall charge of -1, which is the same as our charge here next to our element symbol. So now that we've figured out protons, electrons, and neutrons, we can go ahead and draw our Bohr-Rutherford diagram for chlorine ion. So we'll make our diagram in the exact same way. Make myself a bit more space. So we'll draw a circle to represent our nucleus. We will write the number of protons in there. And I'm just going to look for an eraser because we don't want 18 protons. We want 17 protons. So we have our circle for our nucleus. We have 17 protons in our nucleus, and then we have a total of 18 neutrons, and then we're going to draw the orbits for our electrons. So we'll draw our first orbit, and in our first orbit we will place 2 electrons. We'll draw a ring for our second orbit, and then we'll place in 8 electrons. So we've added in a total of 10 electrons. We still have another 8 to go. So we'll draw a third orbit. And add in our remaining 8 electrons. So here we can see that our valence shell is full of electrons, so this outer orbit has a full amount of electrons. The number of protons has stayed the same, number of neutrons has stayed the same. To also indicate that this is an ion for chlorine, we will draw square brackets around our Bohr-Rutherford diagram, and we will place a negative charge in the, or a negative sign in the top right corner, indicating that this atom has an overall -1 charge to it. And so that is it for drawing Bohr-Rutherford diagrams for ions.